Okay, so we all pretty much know what psychedelic mushrooms do, right? Their secret ingredient, psilocybin, famously messes with brain chemistry. But the real mystery, the one we're going to dig into today, is why? I mean, from an evolutionary point of view, why would a mushroom ever evolve the power to make another animal trip?
So yeah, this is the big question, isn't it? It just seems so weird. What could a mushroom possibly gain by sending whatever eats it on this wild psychedelic journey? It feels like it makes no sense, and that's exactly what scientists have been trying to unravel.
And the effects of psilocybin across the animal kingdom are absolutely bizarre. We're talking spiders that suddenly can't build a proper web to save their lives, cicadas that go into this strange over-the-top mating frenzy. Slugs can literally have seizures. And of course, for humans, there are the hallucinations. This widespread, incredibly strange behavior is what makes this whole mystery so fascinating.
So let's do this right. Let's treat this like a detective case. We've got our key compound, psilocybin, and a whole bunch of really strange events. Now it's time to line up the suspects, which in this case are the main scientific theories trying to explain what it's all for. Here it is, our main player, psilocybin. At its heart, it's a chemical that gets into the brains of a lot of different animals and just messes with the wiring, causing all this unusual behavior. But knowing what it is isn't the puzzle. The real question is, what is it for? All right, our first suspect in the lineup is, well, just dumb luck. Could it be that psilocybin has no real purpose at all? Maybe it's just an evolutionary accident, a random chemical byproduct that the mushroom makes. And at first glance, this kind of makes sense. Evolution is filled with these little quirks, right? These leftover traits like our tailbones or something totally harmless like a widow's peak. So maybe psilocybin is just the mushroom's version of that. A chemical that's just there, with no real job to do. But, and this is a big but, the whole accident theory runs into a major problem. See, making psilocybin is actually really hard work for the mushroom. It's packed with nitrogen, which is often a super scarce resource for fungi. To make it, the mushroom has to use up precious energy it could be using for, growing. Evolution is usually way too efficient to support something that costly, unless it provides a real payback. So it must be doing something. Okay, so if it's not an accident, let's move on to our second suspect. What if psilocybin is the mushroom's bodyguard? Maybe its whole purpose is to act as a kind of chemical weapon to keep hungry critters away. Now, this theory suggests psilocybin isn't your typical poison. It doesn't taste bad, it's not really toxic. Instead, it might work through a kind of mind control. Seriously, it can make fruit flies go haywire and breed uncontrollably or cause ant colonies to turn on each other. These chaotic behaviors could distract the bugs from eating the mushroom or even make them easy pickings for predators. Either way, threat neutralized.
But this theory has a huge hole in its alibi. As a defense system, psilocybin just isn't that reliable. Turns out there are certain insect larvae that can just happily munch away on these mushrooms with zero side effects. They're completely unfazed. So if it's supposed to be a shield, it's a pretty leaky one, which makes you doubt if that's its main job. All right, on to suspect number 3, and this one is maybe the wildest one yet. If psilocybin isn't an accident and it's not a great bodyguard, then maybe its purpose is all about the future, helping the mushroom spread its spores as far and wide as possible. Now get ready for this, because it's a fascinating chain of events. A slug comes along and eats the mushroom, getting a gut full of spores. Then the psilocybin kicks in and causes the slug to have a seizure. This twitching slug becomes a super obvious, easy meal for a passing toad. The toad eats the slug, hops far, far away, and later, well, it poops out the spores in a brand new, nicely fertilized spot. It's this incredible multi-step plan for mushroom travel.
And yet, this theory has a nagging question, too. I mean, if the whole point is to get eaten so your spores get a free ride, wouldn't it be way easier to just be, delicious? Plenty of other mushrooms and fruits do that. This whole complicated, weird behavior thing seems like an overly elaborate way to get the job done.
So where does all of this leave our investigation? We've looked at the top suspects, and every single one has some good points, but also some major flaws. It looks like this case is not going to be solved by pointing a finger at just one culprit.
The simple truth is, right now, there is no single, grand, unified theory that perfectly explains what psilocybin is for. Every idea has holes, and the central mystery is still officially unsolved. But that doesn't mean we're totally clueless. Actually, the leading hypothesis right now is that maybe we've been looking at this all wrong. We've been looking for one single purpose, when maybe we should have been looking for many. Think of psilocybin less like a hammer and more like the chemical version of a Swiss Army knife.
What that means is it's a jack of all trades. It might ward off some insects, but not all of them. It might help spread spores in certain situations with certain animals. It might even have other jobs we haven't even thought of yet. By being pretty good at a bunch of different things, it makes that high energy cost totally worth it, even if it's not a master of any one thing.
So, what psilocybin is really for remains one of biology's coolest open cases. It's just a powerful reminder that even in the world right under our feet, there are still these deep, amazing mysteries to figure out. It seems that when it comes to understanding these fungi, well, I have to say it, there is still so much mushroom for improvement.